In the third episode of How It All Began 60 years ago for the Aerostar and Ted Smith aircraft, the interview with Dick Reese, my dad. In this episode, we're going to talk about the flight control system, an in-flight breakup, how the airplane was built super strong, the main gear design, and one of the Aerostars actually crashed during testing. It was the first one, the blue one, and it never flew again. And don't forget, if you like these videos, please subscribe, like, and ring the bells so that you get the latest videos as they come out. There should be two more of these coming out here over the next couple of weeks.
Let's talk about the flight control systems, because most of the airplanes, if not all of them at the time, were all cables and pulleys.
Right.
And you decided to go with push
Well,
rods.
that was both
and
TR and myself. I've been flying the T-33, which was a fingertip control flying airplane. In your instruments, you're not. It just took slight pressures, but that was because of the tightness of the flight control system.
Mm-hmm.
And I believe it was all push-pull. But that was TR's idea too, because the cable systems, they stretch, and there's a lot of there's movement before anything happens as you're pulling back in the stick, so it's not a real responsive system. Where the push-pull tube is direct,
Instantaneous feedback.
Yeah, as you well know, and that
Yeah.
for the pilot, if you're really controlling the airplane, especially flying instruments, that makes it a lot easier.
Sure.
And it really is less going to go wrong. You break a cable, well, of course, if you break a push-pull tube, but those are, I wonder if that's ever happened.
I'm unaware of that. It'd be pretty hard.
But you've heard of cables breaking.
Oh yeah. So
But
that
TR
was,
fought the Aileron. I wanted to put Aileron trim because we had that in the T-33 too. My thinking goes back to stuff I had been flying.
Mm-hmm.
Aileron trim was very important, but TR just insisted no aileron trim. As long as you burn the fuel equally from the tanks, you won't have the aileron trim.
Yep. That's why if you're having to trim the ailerons a lot, then you've got something wrong in the fuel system. And generally that's going to be a fuel cap leak, because now you've got a suction created on one tank and it's not allowing it to drain gravity feed into the engines. And then what I found with there's an STC aileron trim system, which is, I think it uses model airplane servos. It's a very simple system, but the problem is when you have that, you don't really know whether you're really coordinated or not, which will also cause a differential fuel flow.
Yep.
Or if you got a leak. If you do have a little bit of an imbalance, and you check it every once in a while, especially if you're on the autopilot, you just cross-feed for a few minutes, and you balance it right back out again.
Well, again, that kind of thing is pilot knowledge of the airplane and how to properly fly the airplane.
Yeah.
And boy, I discovered that in his expert witness. The majority of accidents are absolutely pilot error. Now, some of it, or a lot of it, is design-induced pilot error.
Mm-hmm.
Because you can, in the design, induce the pilot to make errors.
And it's interesting, going back, I brought up a topic on the forum about Aerostar accidents. And I was curious. The one thing that made me curious was in-flight breakup. There's only been one as a result of a turbocharger coming off and failing the main spar. And that was taken care of a long time ago with both Malin and Aerostar redesigned that system. But it turned out there's actually quite a few more. There's a handful of them. But all of those were loss of control in instrument meteorological conditions in thunderstorms. So the guys that I call this, what you're saying, these are stupid pilot tricks. They do things they shouldn't do. They fly into a thunderstorm that it doesn't matter what you put into it, it's going to tear it apart. And these poor guys get into that, and they shouldn't have been there, and they end up getting spit out the bottom and smoking a hole in the ground.
Well, as people don't understand, as you well know, for you and I talking, people don't understand the power in a big thunderstorm. It can completely disintegrate an airplane. The pilot ends up losing control on instruments either because he just panicked and the airplane got ahead of him. And once, as you well know, once that happens, you can't catch up to the airplane again.
Yep.
Well, the way you can catch up is stop the airplane in flight
Well, you've talked to me a lot. Here's the father and son thing. You know, I'm sure TR had a lot of those discussions with you, but I got chewed out a lot about even thinking about flying in weather that I shouldn't be in, and so consequently I didn't do it because you have done it, and that's what you were doing in the Air Force was thunderstorm penetration work, and you were actually purposely going out and flying into big buildups to see
Now,
what
it was
it
a
would do.
research program. And the reason I chose Wichita for it, because that's the biggest ones are.
Yep.
We'd have little puffy white clouds 10 in the morning. They'd build to 65,000 feet by 3 in the afternoon.
Yep. Seems to me you told me a story about, was it B-36 maybe, that just literally got just ripped apart, and the engines even got ripped apart.
That was either 54 or 55 over Oak City. A B-36, which is a 6-engine pusher prop with 2 jet pobs further out in the wing, so 10 engines. It was the next thing after the B-29. They were over Oak City, got in a thunderstorm. It completely disintegrated that airplane, including engines.
Yeah.
There wasn't a whole engine left. The crew bailed out. The only one I know about is a pilot bailed out, and for those that you are not familiar with military aircraft, when you're flying aircraft that are going to be flying above 15,000 feet, you're wearing a mask, and you wear a bailout bottle that has oxygen. And so if you bail out at, say, 40,000 feet, 30,000 feet, you're going to die unless you have oxygen.
Mm-hmm.
So the bailout bottle is to make you survive while you're in the chute. You're supposedly trained to free fall until you can see the ground or something, then open the chute. But you know, how many people do that? So the pilot is the only one I know about, and he was written up in Time, Life magazine back in 54 or 55. Well, it happened, I think, either 54 or 55. He was in that thunderstorm. For those that are not aware, a thunderstorm, if you think of a whole bunch of soda straws all standing on end, one next to the other, and each soda straw represents a cell in that thunderstorm. A thunderstorm is made up of a whole bunch of different cells. That's why, not so much out in our neck of the woods, but when the thunderstorm comes through, your next door neighbor may get a lot of rain, and you don't get any rain. It's just because these cells are different. These cells can have shear winds of 500 miles an hour. One's going up, the other's coming down, and the shear is like 500 miles an hour. And this poor guy, when he bailed out, he got caught between these cells on his chute at 30,000 feet or whatever. And he would be in one cell with his chute inflated, and they would take him on up, drift him over the next one, which is going down. Now they'd take him on down, kept switching back and forth with hailstones, without exaggeration. They're softball size and bigger, hitting him all the way down.
Wow.
He didn't have one bone in his body that wasn't broken. His skin was just peppered with this stuff. He survived. So that's the reason the story came out.
Yeah.
But that's the reason there's failures in thunderstorms. It's many aircraft can't take the structure, but Aerostar, as you well know, is a very strong airplane, and it would eventually fail at Aerostar too. But thunderstorms are nothing to mess with.
No, they sure aren't.
In the design of the Aerostar, the first aircraft we hauled to Van Nuys Airport from North, which was about 12 miles away. About 2 one morning, 3 one morning. Ron Smith was in the pickup truck hauling. I was in the cockpit handling the brakes. Fully assembled airplane, of course. Threw it down this 2-lane road. Then we had to get telephone wires pushed up out of the way and kind of jock around, not hit mailbox to the side. And I'll never forget people driving back from bars, seeing this airplane I got there. They were probably pretty drunk. What am I looking at here? So we hauled that airplane back to Van Nuys. We didn't have the production facilities built yet at all. Just to a little hangar, and that's where we did the first test flying out of that hangar. Completed the work on it. You couldn't do test flying out of Van Nuys because it was a major airport. So we had to fly to
Lancaster.
Lancaster,
yeah.
And that's where we did the first flight. We had to make 5 touch-and-go landings there. Then we could come back and do the rest of the work at Van Nuys.
So the first test aircraft, so the first ones at Van Nuys, you're working out of that. Now, obviously, you were doing engine runs. Did they allow you to do taxi tests and that kind of thing at Van
Yeah,
Nuys?
yeah. IL-540s, the 6-cylinder is what we really ended up with.
Right.
I don't think we actually really flew, except maybe taxi tests and this kind of thing, with the 4-cylinder engine. Bert Bannell was a very close friend of TR's. He was a test pilot for, I want to say North American. Very familiar with Aero Commander. Well, he was involved with Aero Commander as test pilot. So he's the one that did the first test flight for TR.
Okay.
Because TR knew him real through Aero Commander days and everything. And he was a super nice guy. And the first flights out of Van Nuys to go to Fox Field, Bert was flying the airplane. And TR keeps saying he was, but he wasn't. Bert was flying the airplane. TR was in the right seat. And they took off, and the engine started sputtering. So TR told Bert, that's just, it'll clear itself out. That's just, Bert said, no way, I'm making a 180, which is what you're not taught to do, but they don't want anything. He came back and just landed down and went to Van Nuys.
Yeah.
And what it turned out to be is we had the, forgot the name, not the fuel filter, but the bowl for the fuel that feeds the engine. The fuel goes in the bowl. It filters out the bad stuff. Anyway, that was on the engine side, the firewall, and why we put it there, I don't remember, but I realized right off the bat that it overheated and vaporized.
Yeah.
And that's so we landed, we took that out, put it on the back side of the firewall, and then next day took off and flew again, and then flew to Fox Field, and then from then on went through the certification. Now that may have been with a 4-cylinder engine. I just don't remember.
I think in the book, Dave talks about that, because that was an interesting fact that the original engines were 160 horsepower each.
Yeah.
And you think about that, so that's 320 horsepower,
Yeah.
and we have more than that in one engine
Yeah.
now in our 700 horsepower version. Then and that may have been a 320. I don't know. I'm gonna kind of
Okay,
look that up.
we all knew that wasn't going to work, but and I'm sure TR knew too. But
Yeah.
that was TR's marketing side. He was really strong in marketing. So the more he wanted to show a whole bunch of different horsepower twin engine airplanes
Right.
for marketing purposes. So I think he really knew that wasn't going to work. So anyway,
So that makes sense.
yeah. Well, that was TR's problem, is he over marketed what he was doing. He was a salesman. He was a better salesman, I shouldn't say, than a designer. He was a good designer, but
He was a promoter.
he was a promoter. He was more of a promoter than he was a designer. And that got him in trouble, I think.
So let's talk about the main landing gear strut, because it's kind of an interesting design because of the mid-wing and the length that it had to be, and the way the old shock absorbers were designed. Talk about the old design and what you did to solve that problem.
Well, I just haven't understood how the shock absorbers work on most general aviation aircraft. The shock absorber's purpose when you're landing is to absorb the shock of landing. But when you first land, you want that to be an easy load, relieving load on the airplane, and it gets depressed more and more. That load needs to go on up so you don't bottom out on the shock. So the typical shock absorber is designed where there's oil in a cylinder and there's a hole halfway up in that cylinder, and so there's a pintle or a wire coming down.
Kind of like a spindle. That's a conical spindle.
Yeah, but I'm trying to think of a better word for it, because most people don't understand what spindle really means. It's a large diameter solid piece of tubing, Anyway, and it's tapered, so it gets thicker at one end and thinner at the other end. So as the gear comes down and as this thing goes up, and it goes into the spindle, it makes the surface area in that hole smaller and smaller, which means that the oil coming through takes more force to go through that hole, which puts, as the gear collapses, it loads up more and more force onto the airplane, so you're not collapsing, hitting out the bottom. Anyway, that thing can move around there, so I never cared for that particular design. I'd never designed landing gears before, but I just thought there must be a better way of doing it. So what I decided to do is have a piston, which is attached to the gear, slide up inside of a tube, and that tube has a top to it, full of oil, and that tube has strategically placed holes in it as you go up. So as this piston comes up, as you're touching down, as the landing gear, the wheels are pushing this piston up, it's starting to close off holes. Holes.
Hoils?
And which then puts more and more pressure for it to push that oil through the last remaining holes, which gives you more and more restriction as you're collapsing the gear. So that's the way we designed this thing, and it turned out to be very, very simple, but it behaved exactly the same for each time, but it gave you the full increasing resistance as you were touching down and collapsing that gear. So that's what brought that about. We did drop tests back in New York. I think the company was Osborne. And that scared me to death. I went back for those drop tests, and it's a pretty big machine. They had the whole gear system mounted, including the struts and everything else, mounted in that system. And I kind of forgot, but I think it raised it up like 10 feet in the air, weighted, and then dropped that thing free fall. And boy, I held my head when that thing hit, because I thought everything was just going to blow apart. But it took that without any problem at all. So I did that a couple times. But so then, ironically, to further test. So anyway, that's the gear we ended up with, and ironically, as a unwanted further test of the gear, Boyd Leidick, our chief pilot, and Monty Kerr, our aerodynamist, and he planned all the flights during the certification. And Phil Copeland, who was a ground crew guy, were flying the Aerostar doing some certification work. And part of that ending of that flight was to demonstrate short field landings, which was part of the certification process. And they were coming in for the short field at Van Nuys Airport. And of course, in this, you're trying to find the limits of the airplane in doing this. So you're taking the airplane right up to its limit before stall to see how short a field you can touch down on. And airplane, being a high performance airplane, if you get to that point and then stall, the bottom is going to drop out of that airplane. It's just going to free fall for however far above you ground are, and when it hits, it's going to hit hard. Well, unfortunately, this is all part of flight testing. In order to find the limits, of the short field approaches, Boyd was trying to find that limit, and as he approached the field, and I don't know how high it was, probably at least 10 feet, maybe 15, 20 feet, I don't know. I was there, but I don't remember the height, but he lost, when I say lost the airplane, he approached stall. And once any high-performance airplane, I should say any, but I think that's probably true, once you get the stall point, everything, the bottom's going to drop out. The airplane's just going to free fall down, which is what happened to Aerostar. So it free fell for whatever the height was and hit the ground hard. We had G meters on board the airplane, and if I remember right, it pulled 16 Gs. And when it hit the ground, the oleos all worked, but it drove the gear attachment up through the wing, so they failed there. So they were sticking up through the wing. creased the fuselage some. I think the motor mounts were still intact. I don't remember that part specific. But anyway, and looking at this afterwards, if that had happened in flight, the 16Gs, I think you could have flown the airplane home. So the damage that was done, I don't think aerodynamically destroyed the airplane enough where it couldn't have continued to fly. So it really demonstrated how rugged that airplane was.
Right.
But anyway, the gear was just like another drop test.
Yeah.
It looked fine afterwards, except it failed the mounting in the wing itself.
So
Anyway, what was beautiful about TR, he was there when this happened, as I was too. And he didn't go up and chew anyone out. He said, boy, that was a shame. But he said, and we had to scrap the airplane.
Was this serial number 1? Was this the
Yeah,
first
this
one?
is the-
This is number 1.
If you ever seen any pictures, it was the blue airplane.
Yeah,
The second airplane was the white and,
the white one.
yeah.
Yep.
They were both identical. But anyway, that was TR. And I think part of this, he was in the business long enough that he realized these things happen during flight testing of aircraft. So, and I think he realized that if you start chewing people out, you're going to take away their creativity and their challenge to try to stretch the limits to see what really does happen, and you're going to ruin the capability of those people to really helping you in the certification. So that I really had to hand to him. He didn't chew people out for making mistakes, because I think he'd been there.
Thanks for watching episode 3. Look forward to seeing you all again in the next one.